It's Hiten Parmar, board member of SAESA, the South African Energy Storage Association. It's a very well-developed group there, looking at all kinds of storage solutions, all technologies, and all topics around storage. And on top of this, Hiten comes with a very, very solid experience in the automotive industry. And as the industry evolves, is also very much involved in e-mobility, which, as you know, relies on storage solutions, and these topics of risk and safety are also very present in this industry. So, Hiten, I'm very happy to welcome you. I'm going to give you the controls right now so you can share your presentation, and I hand over the word to you. Thank you.
Thank you very much, John. Pleasure to join you all today and participate in this session. As introduced, I'm Hiten Parmar, currently representing in today's event as a board member of the South African Energy Storage Association, and will be just sharing some high-level insights on energy storage on the topic of safety. It is a quite detailed topic, but I will just share some high-level insights just to set the scene for the purpose of this event within the 10 to 15 minutes that I've allocated for the session, and then happy to take on further questions in terms of that. So I think, yesterday and today we've seen the context of energy storage in relevance of that, and we'll just cover some of the safety aspects on that. Just as an introduction to SAESA, which is the South African Energy Storage Association, it's really evolving on a mission and vision supported through its constitution to guide policy and allow for accessibility of storage projects, advocate and advance the energy storage industry in South Africa. And its mission is really to create a more resilient and acceptable, efficient, sustainable and affordable energy system in Africa. And a key role on educating stakeholders, advocate for public policies, accelerate energy storage growth, and value to the energy storage industry as a whole. So that's the overview of the association, and certainly active as John introduced in terms of that. So I think some key points to really highlight is that, the earlier panelists and presenters have certainly highlighted the energy transition. I think this image on screen highlights, the traditional energy value chain that we've seen is very central from a generation, transmission, and distribution network as well. That's supplying industrial, commercial, and residential homes from that perspective, and technology has now evolved. The key thing to note here is that we've seen technologies evolve along generation, transmission, distribution, and as end users. With the embracing of renewables and alternative energy generation, we see the developments of the technologies there. Transmission network improving in terms of smart grid communications, distribution network, and also the applications of multiple end users that have evolved from what it was. Also on the demand side, we've seen the applications of inclusions of alternative energy sources and generation means right at the end user. This typically, in the case of rooftop solar, generation in generator systems, microgrids, and also electrification of transport alongside that. What's key to note is that energy storage remains a common denominator across everything else. So you can see within that that you've got the application here, right from bulk generation at utility scale. You've got energy storage at the transmission level, and also at the end user side from that perspective, and also noting that electric mobility is essentially battery on wheels. So we see this application of bidirectional use cases within that. So what's really to highlight here is that energy storage has a key role to play across the energy sector and across all phases of the energy value chain. Just some high-level indication of the types of energy storage. We've certainly got applications of mechanical, electrochemical, electrical and chemical, as well as thermal. So the topic is quite vast. However, today I will just really focusing on battery energy storage systems specifically within the available time. Now, if we look at also expanding these, there's a whole range of services that these can be and use cases that can be provided in the typical power capacity, but importantly within the time scale discharge generation that is required on the energy system. And each technology has its value add and purpose of play within that. Just some brief highlights on that. But we start unpacking that further. Safety is quite critical on this aspect, and the reason is why. We're seeing the developments on energy storage systems that have high energy density than traditional and conventional systems being used. Early days of lead-acid systems, the energy systems have actually evolved to what they are today, and they've become hazardous in terms of energy. And if it is released and compromised, it is released at a fast and uncontrollable rate. This is some examples in 2011 of the NAS system in Japan. 2 megawatt system caught fire and really took several days to take care of by the first responders in terms of that. Similarly, a lithium-ion fire system in the US in Flagstaff in November 2012, a 1.5 megawatt system caught alight. And you know, various systems actually, or root causes were based on this. But I think the key message around this is really that safety is really critical in terms of this, as and where we have high energy density systems being deployed in all applications, either in a home environment, at medium level system, as well as utility scale systems, as well as we see the transition into microgrids, as well as electrification of transport. So all forms of energy storage systems and battery systems need to be mindful of health and safety in terms of that. Important to note is that what is the classification in terms of high voltage systems? Within this, a lot of the reference is at 60 volts DC is considered high voltage. This is really on the basis on the implications of human contact with the system itself, based on the human body resistance, a typical 1 kilo ohm. We then start to have a feeling within that. And obviously, the higher the voltage, the higher the current, the feeling is starts to get more painful, and then eventually lethal in terms of that. And this is where we can see the typical technical values in terms of that, and the reference here in terms of 60 volts and 60 milliamps, we then start to get, so this becomes a health and safety issue. So this is the key thing to note across the board for these sort of systems. We've also seen earlier presentations that these storage systems are now going into high voltage areas, well above 300 volts, which is certainly a health and safety noted to be noted within that. Important to note in terms of the typical safety events that can occur in lithium-ion batteries. From a product perspective, you've got some applications of dendrite growth, separator failure, lithium-ion plating, nanoparticles, as well as detaching from electrodes. So it's important as well to choose the right type of product in terms of not only at a full system level, but also being aware of what components in terms of primary components are being used in certain systems being deployed in all of your projects. Some of the external causes, this also can be either from handling of the system during installation, during transportation, or at end of life. These can be typical mechanical damage, external short circuit, overcharging of the cell, and over discharge of the cell, low temperature recharging, high temperature storage, improper design, manufacturer contamination, and a sequential combinations of all of the above. So you can see that there's a number of factors that are involved in typical safety events. This is important to highlight when you are designing systems, either at a system level of developing a product, or when choosing a product from a supplier to make sure that all of their products do meet the manufacturing guidelines of the systems, and also controlled within quality control in the manufacturing environments. Some guidelines of these include, I think prevention is the best cure amongst everything. typically within these systems, as highlighted earlier, that these sort of energy storage systems are actually hazardous products. In all applications and whatever technology it is, they are declared hazardous, and then specific methods of use and applications need to be aligned towards that. Important around occupational safety, that is with all staff being involved of handling the thing, handling the system at transportation, at storage, at installation, manufacturing, as well as decommissioning, as well as commissioning as well. So everybody that's involved within that has to take care of the safety guidelines, both electrical and mechanical hazards that are involved when handling these systems. In the event of a risk analysis and safety testing, this is important, as mentioned, in production processes, as well as, in a manufacturing environment. Some abuse conditions should also be evaluated at a product level and a system level to make sure that in the event that should some abuse happen in this, both electrically system and mechanically, the product is safe according towards that. Also important is mitigation measures. The necessary measures must be taken to prevent accidents and limiting the consequences. This is really supported to what's called standard operating procedures, amongst everything from a manufacturing environment to transport, to installation, as well as commissioning, and importantly is decommissioning as well as maintenance. These are the things that need to be taken care of to make sure that there's correct procedures being involved in terms of that. And also identification of opportunities to develop the new codes, new standards and regulations. In every country and market, it is important that we have the guidance of the market from the international standards, as well as local standards. Each region has different specific operating conditions, either voltage, frequency, and other grid parameters and grid codes specifically, and these need to be managed in terms of that. This is a visual representation of what was just highlighted. It's important to note the applicable codes in each region, each country, for this that are required for grid connection, as well as energy storage systems. Also, where applicable in terms of the regulations involved. There are various standards that guide the performance testing of energy storage systems that need to be taken care of. And then also in terms of safety testing, there's various international standards that also come into play here. And then also transportation. The main one is UN 38.3 that guides transportation of these devices. And then standards also describing the risk assessment in terms of when installing, when handling these systems, there's a specific assessment and criteria to follow within that. And then also in terms of energy storage system safety and grid connection, also the standards to follow when connecting these systems. So it is quite detailed, and I think sometimes safety is something that is left just by the way. And until such event happens, then it raises a concern. But it's important, as we're highlighting today in today's event, that safety remains critical to be highlighted in all spheres of the energy system as well. Some typical guidelines include, cell acceptance tests and the storage of the systems, pack assembly, that is from a manufacturing environment. And then at end of manufacturing, testing for that, to making sure that these standards and the product itself are aligning to the performance testing, as well as the safety testing in terms of that. There's a number of standards both within South Africa and internationally that are applicable. These are either from the South African National Standards Authority or the International IEC, UN and others that are applicable to the various storage systems. Battery transportation is critical. In most cases, all of these energy storage systems are declared hazardous. And with that, the specific means of handling these, the transportation thereof, need to be also managed in terms of that. As highlighted earlier, UN 38.3 remains a key standard that is applicable to lithium-ion storage systems. You'll also see these stickers being on the various product itself, which also highlights that the specific manufacturer and distributor has aligned to that specific standard, so that when you purchase something, or when you're installing it, or when you're using it, it is already meeting those specific standards, and it's a lesser of a risk by using that specific quality product that's meeting the standards, that there's a less risk in terms of all users, as well as the project implementator, as well as the project user. Usage remains key. This also needs to be taken care of during installation, maintenance, and usage of these energy storage systems, to making sure some things, some matters as the physical environment, temperatures, and other systems are taken care of, to make sure that there's no compromise on the energy storage system. And then importantly, in terms of battery disposal, many of these systems contain specific metals and chemistries, and through that need to be handled accordingly at the end of life, or replacement in terms of upgrades, system upgrades in terms of that. The environmental implications is quite important. Many regions all over the world are embracing the sustainable energy transition, but through that we also need to manage that all areas of the environment are also taken care of. Important that especially within chemical composition of energy storage systems, they include electrolytes, and this is also compromised when these are exposed to the presence of water and humidity, and then also potential leaching of metals into the groundwater that implicate the environment. So it's important to note that when you're designing a system, also taking care of the end-of-life management and also usage of those systems, that in the case of a safety event, there's no contamination in this regard. What we're seeing globally is what's called the Extended Producer Responsibility Regulation that is guiding the full value chain in terms of this. What that means is that every manufacturer, distributor, or importer of electronic equipment, which includes batteries, is guided within this. South Africa recently introduced this regulation, and this also highlights that there's a national ban of e-waste to landfill, which includes batteries. And what is this? What this means, it's promoting sustainable end-of-life management and promoting recycling, which is a full responsibility in terms of that. So this is a key thing to highlight. And this is also highlighted earlier from the lead-acid batteries, which was active since 2013. And as of August 2021, all other batteries are banned, including lithium-ion, from landfill in South Africa itself. So we're seeing many regions, including Africa, embracing this e-waste ban in terms of that. So I hope that's given you a high-level overview in terms of the safety of health and safety in terms of energy storage systems. Please feel free to get in touch with SAESA for any additional information, as well as membership to support your initiatives in all areas, either in a personal capacity or your company itself. But this is a detailed topic, that really requires a deep dive, whether you are a product manufacturer, whether you're installer, distributor, or anybody involved in that, as well as an end user, to making sure that the product you install in your home environment, in your projects, in your vehicle, in your energy storage systems to support the grid and energy transition is a quality product, and you're not compromising anybody, either your workers or the end users, in terms of health and safety. But thank you, John. Over back to you.
No, well, thank you for this very detailed presentation, very much to the point. Actually, my first question is a continuation of what you just said. You've very well laid out all the different certification standards, the key potential sources of hazards with regards to those batteries. But if I put myself in the shoes of an end user, how would I know that these different steps have been respected? How do I know that the product I have gotten installed at my factory or my house is actually safe?
Great question, John, and that's really important. So this is where we look at the standards. So when you look at a data sheet for an energy storage system, it is always important to look at what standards does that specific system qualify to. In every region in South Africa, we have the SAN standards, and internationally, generally the IEC, UL, and UN and others are important standards to qualify. So when installing that, it's important to check with the local authorities, what are the approved standards for these energy storage systems in your specific region and country, so that you know that this specific product complies to that. And that's how you guide that. We see from a regulatory perspective, that is still evolving. We see that also the technology developments in the renewable energy and storage, technology always leads, and regulation and standards need to catch up in terms of that. But generally, it's important to always check with the local authorities what are the regulations and standards for these systems and align to that, and making sure that when you buy a product, you also check that they do meet these specific requirements aligned to either international or local regulations. That's the key thing to do.
That is, if I'm not mistaken, that is more about the manufacturing of the product. In South Africa, when we look at solar specifically, there is something very interesting, which is the PV green card. It's like a checklist for making sure that your installer has respected a certain set of guidelines and rules for proper installation. Is there such a thing for storage products as well? Again, putting myself in the shoes of the end user, if I hire somebody to install a storage solution at my place, is there such a checklist that I should ask them to verify so that I can be more with more peace of mind?
Indeed. So I think there's various stages of what we call stage gates, so when you're buying, as a manufacturer, you make sure that your product complies to the performance testing and safety testing of the product itself. Then, when you're buying a product, you also check those specific standards. However, when you are installing, there is the local grid code and other standards of installation. In South Africa, we have SANS 10142, which is the wiring code, and then other NRS codes that must be followed within that. And essentially, when you are, as an installer, putting something in, you then supply a certificate of conformity, a COC, which means that the full installation has been followed in the correct guidelines of installation, commissioning, and operation. And I think with that certificate, you then issue to say whether it's a storage system, whether it's a PV system or generating system, that it's complied within the guidelines. So in South Africa, we certainly use the COC reference in terms of compliance to installation.
And next question is practical, and I don't want to sound that I see everything negative everywhere. I know that hazard is actually a very small fraction of all the storage installed. But what is the right approach if a storage solution catches fire?
Yes, you said as you started the conversation, it's important to have this discussion because it's always forgotten about. Health and safety is like left, in terms of that. But it's important that everybody is trained, including the first responders and everybody else, in the event of a safety event. In most cases, when installing these high voltage systems, you need specific PPE, which is personal protection equipment, to make sure that you are handling this. But important to note, such as lithium-ion batteries, there's a specific grade of fire extinguisher that is used, specifically. I think it's a class D, if I'm not mistaken. And that, specific, so other typical foam and other types of extinguisher devices are not, typically required or supposed to be used for that. So each type of storage technology is important to note in terms of what is this fire requirements, fire suppression requirements for that specific technology. Each one is different in terms of that. But that is important to note in a local perspective to see what is the typical fire extinguisher technology required for that specific storage technology.
There were, yesterday and today, we've received quite a few questions around battery repurposing and battery recycling. Is there any reason to believe that repurposed batteries are at more risk than new batteries, or is it just similar precautions that need to be taken care of?
Yeah, great question in terms of that. We're seeing emergence of what's called a second life and even third life in small consumer electronics use cases in terms of that. The important thing to follow is, again, the standards. We've seen the Standards Authority introducing various standards that must be applied to second life use cases of batteries. So once these batteries reach the end of life in their first use, before they get repurposed, they must be tested and checked in terms of the state of health and other specific conditions, electrochemistry and others, impedance and other tests to make sure that these products are fit for their second life use in terms of that. But we're seeing really in emerging economies a great opportunity to repurpose these sort of systems, especially when we're seeing the first life being used in terms of high quality type of cells. And when they repurpose from that specific project into a next project, there's still use in terms of that for lower energy demand use cases. And, in terms of especially community development projects, these sort of projects can be repurposed in terms of that. But it's important that, the specific standards and operating procedures are followed correctly in terms of those.
My last question for you today. We've spoken almost exclusively about lithium today. Are there any risks with the lead acid batteries?
Indeed, I think briefly in the presentation I highlighted there's multiple energy storage solutions, and specifically in the technologies, each one has its inherent risks within that, and this is what we need to also look into for that. Indeed, with lead acid batteries, there is the air and environmental concerns within that, with their gassing when charging. So it's important to have correct ventilation in terms of that, because some of the gases are also flammable. You have to correct ventilation and circulation in terms of that, because in the event of a spark, the whole system, the whole room, the environment that they are actually exposed to can ignite and catch fire in terms of that. So, there are hazards within every type of technology, electrical, mechanical, chemical system. So it's important to be aware of that. But just in the case of the question, lead acid batteries themselves do pose a specific, safety concern with that. And also being where physically housed, they are typically heavier. So in making sure that, the cabinet or system where they're installed is also safe in terms of that, from potential longer term use in terms of that. But to sum it up, that, really any specific technology needs to be aware of all parameters involved from a safety perspective.
Well, thank you very much, Hiten, for this comprehensive look at safety and risk with regards to storage.